Here, one illustration of global and non-local periods of the proposed GNLR model. Here, figure A, top, the clean HSI, bottom, the coefficient tensor, top, the global low rangeness of the HSI, middle, the non-local sparsity of the coefficient tensor, bottom, the non-local low rangeness of the coefficient tensor. See reconstructed results of 3D TNN, GNLR and NG meeting. Here, this A, these all are A, top, the clean HSI, clean, top, clean HSI, middle, sorry, yes, bottom, coefficient tensor, clean, coefficient tensor, yeah, the coefficient tensor. This is top, the clean HSI. Okay. Global and non-local periods of the proposed general model. In this model, we top global low rangeness of the HSI. Now, this one, the global low rangeness of the HSI. Middle, non-local sparsity of the coefficient tensor. This one, non-local transformed sparsity. Okay. Middle. Bottom, the non-local low rangeness of the coefficient tensor. Non-local low rangeness of the coefficient tensor. C. Reconstructed results. 3T reconstructed results. This one. In this reconstructed result, MPSNR is 27.26 dB. GNLR, reconstructed GNLR, here 29.3 dB. Here less, here high. And then here in NG meet MPSNR 27.21 dB. Here in this, the global and non-local periods of the proposed GNLR model, global and non-local of the proposed GNLR model, the top clean HSI. This one is clean HSI. Here, this is the global period, N2, N3, N1. This one distance, this is N3, N2, this original image. Okay. Here in bottom, the coefficient tensor, non-local period. This is global, this is non-local period. This height N1, this height N2, here R. And then in this coefficient tensor, X, caps X, small, psi, this is psi or X, X3 e power t. X only. Okay, we'll see. If I tell wrong, I will explain afterwards. I will correct it afterwards. Then, um, in this middle figure, this is global low rankness. Here, the global low rankness of the HSI. Low rangness of the HSI. Here, singular value in y-axis. In x-axis, minimum n2 n3. In this direction, slice 2 minus n1. Here 10 to 400. Here 20 to 400. Here 0 to 10 power 4. Here also minimum n2 slice 2 power minus n2. Minimum n1 minus n1 comma n2 slice 2 comma n3. And then here this output reconstructed results of 3D TNN. Reconstructed 3D TNN MPSNR 27.26 dB. Okay. Here in this middle, this one non-local transfer capacity connected to non-local row networks input side, output side, 3 interconnected. That is global low rankness, non-local transformed sparsity, and non-local low rankness. All are connected. Here, reconstructed results of 3 TNN first. Reconstructed 3 TNN results. Here NPSNR 27.26 decibel. Here, in this non-local sparsity, transformed sparsity. Here, 2D patches stack here. This is P, this is P. Here also P is version P. And in non-local transformed sparsity, this is interpatch redundancy. Interpatch redundancy, ID one direction transform. Here in intra-patch redundancy. Intra-patch redundancy 2D transform. Here number of pixels 1000, 2000, 3000, 4000, 5000. Pixel value 0 to 1 to 3. Pixel value 0 to 1 to 3. And then in GNLR, MPSNR equal to 20.33 dB. Okay. Now, non-local low rankness intra-patch redundancy P, here also P. Then here V-shape 3D patches. Index 0, 100, 200, 300, 0, 1, 2, 3, 4 up to 6. Singular value P square R. Here, this is P square R. This is distance value. Okay. In intra-patch redundancy. NGNIT MPSNR 27.21 dB. Here this center B top in middle, the non-local sparsity of the coefficient tensor. Yeah, that's one mentioned. Here in bottom, non-local low rankness of the coefficient tensor, and then reconstructed this is JNL or NGNIT. Here dB 27.21, 29. This is low compared to above, and then this one second 3D TNN. Third one is the 29.3. Okay. Here recently Live et al. in 27th reference proposed a decompressed SCI DSCI method to capture the low rankness of the image. Low rankness of the image. More concretely, DSCI DSCI method clusters spatial similar 2D fetches into groups by the NSS of HSI and exploits the low rank property of these groups. However, directly grouping similar patches in the original image time consuming and bandwise calculating neglects the spectral correlation in 28th reference of the targeted HSI. To tackle these problems, HETL in 29th proposed a non-local meets global NG meet restoration paradigm to exploit the NSS of coefficient tensors under the matrix factorization. The matrix factorization usually unfold the third order tensor as a matrix along the spectral dimension and then factorizes the matrix into a semi orthogonal basis of matrix and a coefficient matrix. On the one hand, NG-MET explores the NSS of the coefficient tensor rather than the original HSI, which reduces the computational complexity. On the other hand, the method captures the low rank property by the matrix factorization, but fails to maintain the whole structure of a third order tensor. To solve the aforementioned mentioned shortcomings, we simultaneously characterize the tensor-based low-rank Fourier and two non-local Fouriers, considering the fact that matrix factorization destroys the inherent structure of a third-order tensor. We use the three-directional tensor, a nuclear norm 3DNN. In 30th reference, which has achieved great success for image denoising to maintain the global structure of the underlying HSI. Since the coefficient tensor inherits the non-local properties of the original HSI, we utilize two implicit regularizers, that is weighted nuclear norm minimization WNNM and in 29th and the 31 paper block matching and 3D filtering PM3D 32 under the PnP framework, plug and play framework to flexibility and efficiently capture non-local low rankness and the non-local sparsity of the coefficient tensor with a lower time consumption. Okay. Based on the above prior knowledge, we suggest a global low rank tensor optimization with the non-local plug and play PnP regularizers and reconstruct a HSI from measurements. Okay. The GNR simultaneously characterizes three prior information: global low rankness, non-local transform disparity, and non-local low rankness. See figure 1. That is this 3 non-local rankness. This is second non-local transform disparity. This is first global low rankness tensor flow. The contributions of the article include three aspects. Already we have seen last time. Okay. And then since HSI can be naturally represented